right. Yeah. We're at a -12 sine of 4. Make sure you're in radians. Squared plus 8 cosine of 4 squared. That's what I'm getting. And the x and y components of the acceleration vector. And hopefully you've given these a try. What do we got? -48 cosine of 4t and 112, -112 sine of 4t. We're going to evaluate that when t is equal to 1. So -48 cosine of just 4, 31.374. -112 sine of 4, 84.761. Anybody remember the last one? Just curious. We covered it last year, but not very much. We don't do this chapter over and over again like we do like algebra topics. We base it off of sine squared t plus cosine squared t is equal to 1. But as long as they're both the same as far as, the 4t, that's okay. It's okay that there's a 4 there. Well, now we're going to take x over 3 equals sine of 4t. I think it's y over 7 is equal to the cosine of 4. Or do I have those backwards? That's sine and cosine? Oh, cosine and sine. I thought I had it backwards. Cosine and sine. And so x squared over 9 plus y squared over 49 is equal to 1. There's the Cartesian equation, which is an ellipse. So this is an ellipse. Everybody good with that? Pretty simple if you know how to do it, but if you can't remember, then it's impossible. So I'm here to remind you. Students fail to find the velocity, acceleration, speed, and position of particle. Particle moves in the plane so that its position anytime is given by sine of 4t cosine of t and y equals sine of 2t. Find the velocity and speed of the particle when t is 5 pi over 4. Velocity. Well, they're really talking about the velocity vector. And it seems like, well, velocity and speed, isn't that the same thing? Velocity has direction, speed does not. But in this case with vectors, this is kind of a much different question. These are two very different. Anyway, v of t is equal to, let's take the derivative of this first times the derivative of the second, and I put the negative out front, plus the second times the derivative of the first, and then the derivative of y is 2 cosine of 2t. And we're supposed to evaluate this when t is 5 pi over 4. Well, let's find 5 pi over 4. There's 5 pi over 4, and it's negative square root of 2 over 2. Negative square root of 2 over 2 is the cosine and the sine. We have negative sine of 5 pi, because the 4's will cancel when you plug that into the first sine. Then sine of 5 pi over 4. Cosine of 5 pi over 4. 4 cosine of 5 pi. And then 2 cosine of 5 pi over 2. Yikes. That product rule makes stuff pretty long sometimes. Five pi. Well, that's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. That's over here. And the sign of pi is 0. So if this piece becomes 0, this happens to be negative square root of 2 over 2, but it doesn't matter now. Cosine is also negative square root of 2 over 2. Cosine of 5 pi is the same as cosine of pi. That's negative. So times negative 4, that's negative 1, I mean. And then cosine of 5 pi over 2. 1 half, 2 halves, 3 halves, 4 halves, 5 halves. The cosine of pi over 2 is 0. So that's just simply 0. That piece is 0 right there. And the 4 and the 2 cancel. I'm looking at 2 squared of 2, 0. Speed. Well, let's put it this way. 2 squared of 2 is about 2.8, right? A little less than 3. So this vector, this velocity vector, they're not asking you to graph it, but it's 1, 2, almost 3. And there it is in standard position right there. There's 2.8, comma 0. Well, if you have a horizontal or a vertical vector, well, then the length is just, it's 2 squared of 2. But if you didn't realize that, it's the square root of, it's the Pythagorean theorem, right? It's the magnitude of the velocity vector. So if I square this, 2 squared is 4, square root of 2 squared is 2, and 0 squared, of course, is 0. That's square root of 8. I'll be darned, it's 2 square root of 2. Oh, yeah. Because if it's a horizontal or vertical vector, then we already know what the length is. It's when it's not. It's when it's at a different angle, then we kind of have to do the Pythagorean theorem. But if you don't remember that, you can still do the Pythagorean theorem. You're going to get the same thing. Draw the path of the particle and show the velocity vector at t equals 5 pi over 4. I think I already have it in here from last period. Parametric. There's the first. There's x. There's y. If you zoom 6, that sets it up for trig, but it's a really small graph. So if we go window, how about, I think I moved it negative 3 to 3. Negative 3 to 3. There it is. I think it looks like this. I missed a little bit at the bottom. All right, what does it mean when it says, well, we drew the path. We got that. Show the velocity vector at 5 pi over 4. Here's what they would like you to do. First, we decide, well, where is the particle when t is 5 pi over 4? You go second, calculate, and we're just calculating. There's not a whole lot of choices for parametric, just value and a lot of derivatives. So where is the particle at 5 pi over 4? It's up at the top. It says it's at the point 0, 1. Particle is up here. And now we want to represent its velocity at that point. And if I look, this is about a little less than 1 wide. So if that's at 1, 2, 3, here's the 2.8. So we're going to take that vector and we're just going to start it where the particle actually is. And so now we're representing where the particle is and how fast it's going and what direction it's going. Now see, there's nothing tricky. C is not a trick question. Is the particle moving to the left or to the right? Well, it looks like to the right. Not a trick question. The vector is pointing to the right. I grabbed this one because this is just some other ways to ask questions about vectors, which is Really exciting. Here we go. A moving particle has position x and y at time t. The position of the particle at time t, oh yeah, we got to do, this is kind of old news. This is an initial velocity or initial value problem. Initial value, we've done these. And the velocity vector at time t is given by, here's the x, here's the y, and I really consider, this is v of t, but I really consider that the first derivative also. Find the acceleration vector. That's just taking the derivative again. This is 1 minus t to the negative 2 and 2 plus t to the negative 2. So the acceleration vector should be 2t to the negative 3 and negative 2t to the negative 3. Now they're asking us to evaluate this when t is equal to 3. I just did the derivatives of both, right? Oh, how about 2 over 27, negative 2 over 27. 3 to the third is 27. I'm really not showing this one for letter A. That's nothing new. B's new. Find the position of the particle. It's new with vectors, but it's really an old question. If we have the velocity and we have an initial value for the position and we want to back up to position, we integrate. So it says find the position of the particle at time t equals 3. So x of 3, the position, is equal to, well, we know that it's at position 2 when t is 1. So we'll integrate from 1 to 3 because we're going from velocity back to position. So we need to integrate. And this is 1 minus t to the negative 2 dt. So we're grabbing the velocity. Everybody good with the setup? All right, let's power through the math here. 2 plus t. See if I add 1, that's t to the negative 1. I need that to be a negative, so I'll put a plus there. All right, 1 to 3. 2 plus 3 plus 1/3 minus 1 plus 1. All right, plug in 3 minus plug in 1. This is just doing integral. We've done this a lot. 9/3 plus 1/3 is 10/3. 10/3 minus 6/3 is 4/3. 6/3 plus 4/3. I'm getting 10/3. Now we kind of have to do that one more time, except I think it's starting at 6 instead of 2. 6 plus integral from 1 to 3 of 2 plus t to the negative 2. There's the setup. So we're going backwards. Let's get through the math there. 6 plus 2t. Let's see if I add 1. That's t to the negative 1, but I need that to be a positive if I took the derivative. So minus t to the negative 1 from 1 to 3. Six plus 6 minus 1/3 minus 2 minus 1. 18/3 minus 1/3 is 17/3. Minus 3/3 is 14/3. 6 plus 14/3. That's 18/3 plus 14/3. I'm getting 32/3. Hope that's right. I think it is. That's what I got last period too. Any questions on B, backing up? That's kind of old news, but new to vectors. We haven't talked about that yet. All right, here we go. Letter C. There. For what time t greater than 0 does the line tangent to the path of the particle at x and y have a slope? All right, so now we're talking about derivative, but in terms of slope, dy over dx. That's what I think of when I see slope, dy over dx. But I think of the velocity as the first derivative. So I think this is the dy. I think that is really the dx. Because I consider velocity the first derivative. So we want to know when that slope is 8. Now, this is the first thing I think of. Where is that 8? Then I think, well, first derivative is velocity. So 2 plus 1 over t squared, there's the dy, over the dx. 1 minus 1 over t squared. Where is that equal to 8? That's the question. There's the setup. I think that's the tough part. Now we have the easier part of getting t by itself now. Here's how I would do it. Well, maybe this is better. 2 plus 1 over t squared is equal to 8 times 1 minus 1 over t squared. Maybe we do this. There's a couple ways to do this. How about 2 plus 1 over t squared is equal to 8 minus 8 over t squared. If I add the 8 over, that's 9 over t squared. That should be a little lower, it's t squared, equals 6, right? Minus the 2 over. 9 equals 6t squared. T squared is 3/2, so we divide by 6. And then finally, I'm just going to have the positive, because if I remember right, up here it says t greater than 0. So they don't want a negative value, they just want a positive value. That's one way to finish it. The other way, this is kind of my go-to. I'd multiply everything by t squared up here. And it'd be 2t squared, you don't have to write this down, plus 1 over t squared minus 1 is equal to 8. Then you multiply that up there, and then you get it by itself, and you end up with the same. I like getting rid of the complex fraction. D, I think, is the real doozy. It's a tough. I think it's a tough question. No sarcasm at all. I think it's hard to set up, and then the math is really easy. Read it. See if you can set it up. Maybe you can, maybe you can't. Give it a try. I'm going to do it here in about 1 minute. How would you interpret this question? I think it's a tough one. But I guarantee you're all smarter than I am. No doubt. You maybe don't know as much of math as I do, but you're all 10 times smarter than I are. I like your thought. I do like the thought. You're kind of on the right track. Just in a little different way. Oh, I like some of the thoughts here. But you know how to finish it. It's really easy. Really easy. Beautiful. I love it. We got it. So we got one. Nice job. Now how to finish it. All right, I'll let you off the hook. There we go. It says the particle approaches a line as t approaches infinity. Find the slope of this line. Show the work that leads to your conclusion. Let's talk about the slope. It says it's approaching a line. Let's talk about this. What's the slope? Give me a slope of a line. 5. Write a constant. So it's approaching a number, is what they're saying. What do you think of when you hear slope? Anything? Does anything come to mind as far as calculus is concerned? dy over dx? Yeah. Right? And we have the dy over dx right there. and we're approaching infinity. What does that suggest to you, approaching infinity? Limit, right? Yeah, limit. So letter C, I'm way out of room here. C, the limit as t approaches infinity of the slope 2 plus 1 over t squared and 1 minus, is that what it is?
It's letter D.
Yeah.
1 minus, what is it?
Letter D. You could see it.
Oh, D. Yeah, that's it right there. That's the setup. Now the finish. What's the first step you should always do on limits? What do you think? First step. No, but I like that thought, but no, it's even easier than that.
Just plug it in.
Just plug it in. See if you can get anywhere just by plugging it in, plugging the value in. Does this create a problem, or we got an answer? Yeah, what's 1 over infinity?
0.
0. It's 2. 2. There we go. I told you the math is, I think the math is, at this point in your career, math career, that should be fairly obvious, I hope. But setting it up that's a doozy. That takes a lot of things and putting it all together. But that's what AP is all about. Taking concepts we've done, put them all together, see if you can answer the question. That's why we scale the crap out of the tests, because they're tough. They're really tough. All right, here's what I'd like you to do. On my schedule, I have an exit ticket for you guys, which I don't do a lot. I'm going to try to do this a little more. I'm going to try to kind of use them to get you ready for the test. Oh, anyway, what did I do with it? It's there somewhere. No, that's not it. Oh, here's my schedule. Right here, it's 3 questions. Wednesday, 29. Exit ticket right here, and it's only 3 problems. It's calculator problems. Give them a try. See if we can get them done before we get out of here. You got 5. See if you can get them done in 5 minutes. You can't, no big deal.